these bunch of laws are called index laws. You should have seen some of them already, so I'm going to go through them really quickly. So if your base is the same and your powers different, or it doesn't really matter what they are, but they are times, you can add your powers. If your base is the same, as long as your base is the same, you can, and it's a divide sign, you can take your powers. It always has to be the top one, take the bottom one, however, so that order has to be consistent always. If your base and power is in a bracket and there's another power, you can times the powers. If there's a bracket and a power at the back of the bracket, you need to make sure you apply that power to both of those, any of the terms that are inside the bracket. And same with divide, you need to make sure both of these terms get a power of n. Anything to the power of 0 is 1. And if there's a power of a power that's a negative, you can flip the fraction around and make it go on the bottom, hence the negative power just changes to a positive power. And similarly, if there was a negative power on the bottom of the fraction, you can just flip it ahead and then it just turns into a positive power. So let's just go ahead and give those rules a test. So with example 10a, you have to simplify the index laws. So 3 to the power of 5 times 3 to the power of 4. So as you can see, the base is the same, right? So that means you can add the powers, because that's the rule over here. So you can add the powers, you can go 5 plus 4 as a bit of a working out, or if you're really good at it, you should be able to write 9. Alright, let's do B, 5 to the power of 3, 5 to the power of 5. As you can see, the base is the same, so you can subtract the powers. Now be really careful, you write the base, but you always go from the top one, take the bottom one. So your order has to be 3 take 5, meaning you get 5 to the power of minus 2. So do not accidentally do 5 take 3 for that one. Always has to be top, take the bottom one. C, your answer is going to be m to the power of 4 times 3. When there's a bracket, you times, so which is going to lead into m to the power of 12. Now, just a bit of a side note, your answer for this one can also be written as a non-negative power. We don't really like negative powers, so all that means is you just write, you just think about what's the fraction, how do I make 5 to the power of negative 2 into a fraction? Well, at the moment, the easiest way to make it into a fraction is dividing by 1, and in order to just flip it against that fraction, 1 comes at the top, and then the 5 minus 2 goes to the bottom, but because it's swapped, the minus goes away, so it's just going to be a positive 2. Right, so write as power of 2. So what we're going to do in this case is figure out how to write 16 into a power of 2. Well, 16 is same as, well, let's figure out the factors. It's 2 times 8, it's 2 times 4, it's 2 times 2. How many times does 2 get times? Well, it's 1, 2, 3, and 4, so I figured out it's 2 to the power of 4. So with B, it's really similar, so I could write it as 1 over 2 to the power of 4. You have to make sure that, it's not in a fraction form, so all I have to do is make sure it goes at the top of the fraction, so all I have to do is write 2, and then change the plus 4 to a minus 4 if you want to flip it against. So that's just the rule when you want to flip it against the fraction line. Right, C, anything to the power of 0 is 1, so your 2 to the power of 0 will end up being 1, so that's your answer. D, if I want to figure out what 4 times 2 to the power of n simplifies down to, I need to figure out what 4 is in terms of 2, so I can write the factors. So hopefully you already know that 2 squared would be 4, so I can rewrite 4 as 2 squared, and then 2 to the power of n. Now using the index laws, I know that these two base is the same, so my base is going to same, and then the power is going to add, so it's going to be 2 plus n. E, I've got 2 to the power of m, and then I need to figure out how to write 8 as a power of 2. So if I do my split, so I've got 2 times 4, and then I've got 2 times 2, so hopefully you can see, even without a calculator, you can obviously use your calculator to figure it out, but I'm trying not to, because, well, I actually don't have a calculator with me at the moment. But anyway, 2 to the power of m, and then divide by 2 to the power of 3. Now, you notice that the base is the same, and that means you can use index law, the one with the divide, meaning you do m take 3, and that becomes your answer. So you should be able to do all of these questions now before you move on. But I'm going to keep going on. You can pause the video, do those questions, and then come back. Example 12. Write in the simplest form without brackets. Now, if there's lots and lots of terms inside the brackets and there's a power out the side of the bracket, you just need to make sure that every term, everything inside the bracket gains that power of 4. So all I have to do for this one, right, I'm just going to copy it first, is make sure the -3 gets the power of 4. So this will look something like this. Make sure you have a bracket. And then make sure the A2 gets the power of 4. And then we just simplify it. -3 to the power of 4, you can do it on your calculator. It's 3 times, I'm just going to maybe write it over here as a bit of a working out because I don't have my calculator. So that's 9, 27. I'm pretty sure that is 91. So that'll be 91. The negative goes away because there's even amount of negative numbers. And then A, and then 2 times 4 for the power. So it becomes 8. Alright, for B, let me write it all out first. As I said, every single thing in that term gains the power of 3. So -2 gains a power of 3. A squared gains a power of 3. And then B gains a power of 3. I don't need to write a bracket for that because it's just by itself. So I'm going to just have to simplify that one. So -2 times -2 times -2 is 8, -8. And then A squared to the power of 3 would be a 2 times 3, which is 6. And then B to the power of 3 on the bottom. Easy. So you should be able to do this question as well. So now example 13, write without negative indices. Now for this one, as I said, all you have to do if you want to get rid of the negative indice is just flip it across the fraction line. So as you can notice, this one has to be flipped across the fraction line and this one has to be flipped across the fraction line. B squared can stay where it is. So I'm going to write B squared where it is. So I'm going to move this one first. Basically, all I have to do is move it to the bottom because at the moment it's at the top. So I just got to move it to the bottom and then the power just turns into a positive automatically. So with C to the power of -1, I just got to move it to the top of the fraction bar and then that automatically just gets rid of the minus. So there we go. If I simplify that a little bit further, we like to write it in alphabetical order. So B squared would come first. C to the power of 1 is just C. And then A to the power of 3 would be on the bottom. So you should be able to do question 8 now. Example 14, write 2, 1 minus n in non-fractional form. So for this one, we need to figure out how to write this into a non-fractional form. So I'm going to expand it using the one of the rules, index rules. So it's going to be 1 over 2 to the power of 1. Actually, I'm just gonna apply a negative and bring it to the top. Let's do that one because that might be easier. So what that means is overall it has to gain a power of negative. So it'll be 2 power of negative, and then the original one stays. And I'm just going to simplify it. So that'll be 2. I'll just expand that. So -1 minus 1 times -n is a positive n. I'm just going to rewrite that so it looks like a little bit neater and take 1. Then that should be my answer. And that's it. You should be able to do every single question on this page.